All right, today we're going to be talking about groundwater and the different types of water tables or aquifers that we see under the Earth's surface. So groundwater just refers to any water that we have stored within the open spaces or pores of our bedrock. So it might be a little bit surprising to think about rocks because we think of them as these solid things, but we actually find out that there is a lot of open space inside them, and that open space stores air and it stores water down below the Earth's surface. So when we go and we look at this, groundwater is very important. It is a big source of fresh water. It stores about 14% of all of the Earth's fresh water. Okay, and then again, this is just any water that's stored within those pore spaces. Okay, so when we start talking about groundwater, there are two terms that we need to know, and those terms are porosity and permeability. So porosity is just all of the open spaces in our rocks. So these are any open spaces. And when we talk about a specific definition, this is the volume of the open spaces within a rock. So these include any pore spaces, any fractures, joints, or different like dissolution pockets, and we'll just call those different voids or cavities within the rock. Permeability tells us how easily water flows between the pore spaces. So this is really the interconnectedness of the pore spaces. So it tells us how easily water can flow. So I'm just writing water flow potential. So when we start to look at different things, again, when we talk about porosity, I usually think about like a sandstone that has large grains coming together. So the pores are all of these open spots, and again, they can be filled with water. The water will stick around the grains, and then it can also have air. So water, air, and then the actual grains. Now, depending on the size of the grains and their shapes, these pores will be bigger or smaller, and then they'll be more connected. So if the water can easily move through, that tells us about the permeability. Okay, so when we go and we try to understand things, a couple things to remember. If we have high permeability, then it flows easily. And if it's low, then we get, no or low flow. I'll just write no flow for now. All right, so this is really important when we start to look at our water. If we have a material that has high porosity and high permeability, then it will be able to store a lot of water and it would make a good aquifer. If we have something that maybe it has some porosity, it has pore spaces, but a low permeability, maybe the grains are multiple sizes or they're locked together really closely, then we'll have a low permeability, and that means the water won't be able to flow through it very well. So if we have a material that slows the amount of water that moves, so water can be stored within it, but it doesn't flow very well, we call that an aquitard. Or if the layer has no pore spaces, and so the water can't get in it, and it certainly won't be flowing through it, then we call it an aquiclude. It excludes the water, so it's an aquiclude. So those are three words: aquifers, aquitards, and aquicludes to know about. And I can put them up really quickly. So that we have that, again, an aquifer, an aquitard, and an aquiclude. Okay, so an aquifer stores water, and it's going to have a high porosity and permeability. An aquitard slows or restricts water flow. Often it will have porosity, so it might have decent porosity. So we'll write some porosity and then low permeability. And an aquiclude, this one, there's no flow. So this has a very low porosity and low permeability. Okay, so 3 terms to know about. So for this, with the aquiclude, we'll have 0 flow of water. Okay, and some people do use these 2 terms interchangeably, so don't be surprised if you happen to come across that in a book. Anyway, those are the definitions we'll use for today. Now when we go, and we're going to be focusing on our aquifers, so these are those layers that store the water. The first question is, how does the water get into the system? So if we want to draw a landscape, here's our land surface. We can put a tree here, just so you have an idea. What we're looking at is a cross-section through the landscape, and we want to understand where all of these layers are. So if we want to imagine we have a cloud and it's raining, so we have our precipitation. When the water hits the ground, it can flow down the surface as runoff, and it can go into a stream system. But a lot of it infiltrates into the ground. And as it moves into the ground, it's going to keep going down below the surface through all of those pore spaces in the rock until it reaches a layer where all of the pore space is filled with water. And so what we call that, it's going to move down. We're going to get to a point, I lost my blue pen, we're going to use this purple one now. It will get to a point where we reach the water table. So the water table is this point, and the whole definition is that down below the water table, all pore spaces are filled with water. Okay, I'll go back to the black pen, it doesn't work. So the pores filled with water. So everything down here, all that open space is all water. Above this is our area of aeration. So the pore space right at the surface is going to be mostly filled with air and a tiny little bit of water around the grains. And as we go down, the amount of water in the grains is going to start to increase until we get to that water table. We kind of transition. So this area down here where the pores are all filled with water is called our zone of saturation. Okay, the area above, so this is our zone of aeration. So we have some air that's present, and if we want to look, there will be some sort of transition zone right through here. So this is where it's kind of transitioning and there's more water present. And some people like to really point this out. This is the capillary fringe. So we'll write that over here. Capillary fringe. And that's just that transitional zone going down into the water table. So Really, this just tells us more about that water table. Again, it will be at this position. It's not permanent. It's not stationary. It will rise and fall depending on the inputs, our precipitation, and our outputs. So if we go through a period where there's not a lot of precipitation, a dry period, the water table will lower. If we go through a period with more snow melt and more precipitation, it will rise. It kind of recharges at these times. Or if we put some wells in and we start to extract our water, it will also lower our water table. So just remember, it's not a permanent position, and it will fluctuate depending on what's happening in the whole system.